When you have the same base, same exponents, you add them. Carrying on. So when we have two bases in division, what do?
Minus.
Yeah. So we go 4 minus 7, so we get m to the?
-3.
-3. What do we have to remember when we're dividing and the second term has a binomial exponent? We're subtracting the whole thing, correct? Distribute. So we get 2x plus 1 minus x minus 3, technically, with an equal sign right on the left-hand side because these are all equal, their expression, equals m to the 2x plus 1 minus x plus 3, and then we there we are. 2x minus x is x, 1 plus 3 is 4. We talked about negative exponents already. If we have 2 to the negative x, how do we make it positive? Well, it's currently in the numerator. So we can drop it to the denominator and we get 1 over 2 to the x. So we have m 2 to the 3. What are we going to get when we have 1 base 2 exponents? What do? We multiply. Yeah. So we get m to the 6. And this one is going to be m to the 6x plus 2. There's a lot of things. So you got 6. What happens when we have an exponent of 0? We did this yesterday.
Swap for 1.
Comes a 1, so we get 3. Now in grade 10 you were taught about rational exponents. We've talked about this already too. This little number on the bottom drops underneath and it becomes the index, and the 1 stays as the exponent, right? So if I drew my little radical symbol, this 2 drops in front and becomes the index, and then 3 to the 1 drops underneath. So really that's just the square root of 3. More often than not, we go from the square root to the actual exponent, not the exponent to the square root, but we're practicing both ways. So this one, the 3 would drop underneath as the index, so it would become 3, the cube root of 8 to the 1, which is actually 2. So we work backwards and forwards, because sometimes we need the exponents in order to make them common base and work with them, but sometimes people need to be able to turn them to a radical to actually reason through the math. Like a lot of people don't see 8 to 1/3 is 2, but they do see the cube root of 8 is 2, right? So you have to be able to move back and forth. So this one, what would this be? The square root, so I don't need to put the 2, but I'm putting it there for effect. The square root of 16 to the 3. Now this is also something you were taught in grade 10. 16 to the 3 is a large number. Do you agree?
Yeah.
So you can either do the square root of 16 to the 3, like that, which is harder to do in your head, or you can do the square root of, why am I writing the 2 again? Go up. Or you can write the square root of 16 cubed, which is a lot easier to do in your head. You'll get the same answer. Square root of 16 is 4 cubed, which is 64. And then I'm going to prove the square root of 16 cubed. My computer catches up to me. Same answer, right? All right. So I want you to, we're going to look at these ones. So I have 4xy to the negative 3. We want to write these. We want to do the math and then write them with positive exponents. So there's no math I can do here. But so this is to help you, because people in grade 10 mess this up all the time. If I have, for example, 4x to the negative 3, they'll tell me that's 1 over 4x to the 3. Problem is, this 4 is to a what exponent?
1.
It's to a 1. So I will put this on here to stop myself from dropping it under, because that's not actually true. Just the x would drop, correct? So this is 4 to the 1, x to the 1, y to the negative 3. So what am I going to actually get? 4x over y cubed. So do you see how writing that exponent might be helpful? Of 1. So this one We get 15 to the 1, 5 to the 1. And then we get y to the negative 3 minus y. What do we get? Y. So we can do this two ways. We can go take a 5 out of both, so I'm left with 3. And then this would be y to the negative 4. And then I'd have to drop it to the bottom. So I would get 3 over y to the 4. So we can do it that way. We can do the math first, then move the exponents, right? Or we can make our exponents positive first, then do the math, which I personally prefer. So if I have 15y to the negative 3 over 5y, I would personally drop the y down, so I would get 15, 5 times y to the 3. And the 15 and the 5 cancel, this becomes a 3, this becomes a 1, and I get 3 over y to the 4. I personally appreciate turning the negative exponents positive first, then doing the math. Make sure you box your answers because you're loud and proud that these are the correct answers. When it's division, that's what I do. So this one, let's just do our basic math. 3 times 5 is 15. X to the 3 times x to the negative 2 is x to the what? 1, because you add exponents. And then y to the 1 times y to the negative 4 is y to the? Yep, y to the 1 plus times y to the 4, y to the 5. All right? Okay. Look at where I'm going. Here. That was a little reminder of our exponents. Yeah, we're going here. That was all grade 10. Why the heck do we need exponent blocks? Well, everything we've solved so far, the variable has been not in an exponent, no matter what we've done. Linear, quadratic, cubic, rationals. The exponent has not been a variable, correct? But now with exponential equations, we'd have 2 to the x, or 3 to the x, or a half to the x, remember? So now our actual variable is in the exponent, and how do we solve that? Well, there's two ways. We're only learning one today, and it's people's favorite. So what we have to do is, if I gave you this, 2 to the 5 equals 2 to the x, what would you tell me x has to equal if that's a true statement?
5.
X has to equal 5. We agree?
Yes.
Okay. If I gave you smiley face to the sad face equals smiley face to the A, what must A equal? Sad face. Doesn't have to be numbers, correct? What are we ultimately doing here? We're making sure that our bases are the exact same. We only have one base on one side, one base on the other. If I have more than one base, I have to put them together. So I have one base on one side, one base on the other, smiley face, smiley face. And then if they're the same bases, I could say, well, the exponents must equal, or this wouldn't be a true equation, correct? So currently, I have 2 to the x minus 1 equals 8. What base can I make them both be? We always make them be a smaller base, not a larger base. 2. So we have 2 to the x minus 1, and 8 is 2 to the 3. Now what can we say? 2 to the x minus 1 equals 2 to 3. If that's true, and these are both the same base, then this exponent must equal that one. Is that true?
Yeah.
If they're the same exponent, then this is a true equation, right? So my next step after I make the same base is I can just set the exponents equal and solve. If 2 to the something equals 2 to the something, then I can just set those somethings equal. Add my 1 over, and x equals 4. Now you guys, this is a solving, isn't it? Aren't we solving for a variable? When we solve for a variable, can we check it two ways? 1, plugging it in, seeing if left side equals right side. 2, y1, y2 in my calculator. Every single time. There's two ways to check these. Every single time it's a solve. Every single time you're given an equation in grade 12, 11, 10, in university, if you're given an equation and you're allowed a calculator, you can y1, y2, both sides of the equation, and see where they intersect. Correct? So let's try it out. But we can also check it algebraically. So I checked it that way, but I can check it with my calculator too. I get 2 to the power of x minus 1. Now my exponent pops up, correct? If you have a TI-83 and some of the TI-84s, your exponent might not pop up. Well, the only way that it knows that that whole thing is an exponent is to put it in what? Brackets. So if you have a calculator whose exponent does not pop up, you have to go 2 to the power of brackets x minus 1. If you don't do that, it's going to think it's 2 to the power of x minus 1, which it is not. Okay? And then 8. Zoom 6. Now I know my answer should be 4, correct? If my answer was 20, x equals 20, I would have to make sure that my x max was at least 20, right? Because it can't calculate what it can't see. So if you're looking, if you've already solved it, and the great thing is if you've solved it, you know what your x max needs to be. So if you solve it and your x equals 50, then I need to go to my x max and make it be at least 50, or I can't find it on my calculator. So second trace 5, enter, 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 and I get 4, because I only care about the x, right? Same answer. Okay, B. What base can I make them both be? 3. Can't make them both be 9 because 9 squared is 81, right? Remember, we have to make it a base to an exponent, not multiplication. So some people say, well, 9 times 3 is 27. Cool. But we want to make it the same base. So we can go 9 is 3 squared. And then I always put my exponent in brackets so I don't forget to distribute. And 27 is 3 cubed to the x. Distribute through, and we get 3 to the 2x minus 2 equals 3 to the 3x. Now that my bases are same, I have one base on one side, one base on the other. 3 to the something must equal 3 to the something, correct? Then those somethings must equal. Do you understand what I'm saying when I say that? Like if I had smiley face to something equals smiley face to something, then the somethings have to be equal if that's a true equation. If you have an equal sign between them and that's true. So after I make this base be the same in this one, and there's only one base on either side, then I can set the exponents equal. So I get 2x minus 2 equals 3x. If I have an x on one side and an x on the other, I'd get them together. That's my first step. So I subtract 2x, and I get negative 2 equals x. And then I'm proud because it's correct. Halted there for a second. Now, do I move on and just hope for the best, or do I check it?
You check that.
Check it. So I'm going to get 9 to the negative 2 minus 1 equals 27 to the negative 2. So this is 9 to the negative 3 equals 27 to the negative 2. Come on, calculator. So I get 9 to the negative 3. 729. 9 to the 3 is 729. So 9 to the negative 3 is 1 over 729. Because if I go math, enter, enter, that's what it is. Right? And then I have 27 to the negative 2. And I go math, enter, enter. 1 over 729. I don't ever want to write a rounded decimal as my check. I want to write 1 over 729. And you guys can do this algebraically anyways. You can go 9 to the 3 is 729. Okay, well I have to drop it to the bottom to make it positive, so it's 1 over 729, right? 27 to the 2 is 729, so that's 1 over 729. Okay, we talked about these yesterday. I have a base 16 and a base a half. How can I make a half be 2? I talked about this yesterday. What did I do to make that third be 3? Make it to a negative 1. So I can make 16 be 2, but I'm going to do that in the next step. I don't want to lose people. So then this is going to be 2 to the negative 1, x plus 4. Remember to move this. This is 2 to the 1. But I want to make it be a 2. I can move it up here and be 2 to the negative 1, right? We did this yesterday with the third. We did. We had to make the third be base 3 and show that it reflected in the x-axis. Okay, so then I can make this one be 2 to the 4. equals 2 to the negative x minus 4. The common error is going to be forgetting to distribute. Do you think they'll have the answer to you forgetting to distribute?
Probably.
Yep, they absolutely will. So now I have 2, base 2, base 2. So then this exponent must equal this exponent. So I get 4 equals negative x minus 4. Add 4 over. 8 equals negative x. Divide by negative 1. X equals negative 8. And then we can check it. I get 16 equals 1/2 to the negative 8 plus 4. Oh my gosh, really? And then I get 16 equals 1/2 to the negative 4. We can flip 1/2 to be 2 over 1 to the 4. And 2 to the 4 is 16.
Do we have to write out the check step, or can we just do it in our calculator?
If it asks you to verify, you do. But if it doesn't ask you to verify, you do not. D, people will stare for life. And they'll say 5, 2, and 40. What base can I make it be? You can't make it be a base, right? There's no base you can make it be. But is there something we could do?
Divide by 5.
We can divide both sides by 5 on this page. Because, can we do 40 divided by 5 in mathematics? Have we been, like, since you were, I don't know, grade 4, you learned you could do that. So you're allowed to divide 40 by 5. That is a true mathematical thing.
Yeah.
So I get 2x equals 8. Now can I make them be the same base? Yes. 2x equals 2 cubed. And then x must equal 3. E, star, 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 star. People don't, you know what most of you will do? You'll convert this to a log once we learned how to convert to a log. But it's so much easier if you remember that you can actually make this be the same base. Whenever you equal 1, you can change 1 to the other base by doing it what? To the power of 0. Anything to the power of 0 is 1, correct? I need base 6, don't I? So this would be 6 to the 2x minus 3, and 1 is the same as 6 to the 0. Good thing is, if you forget that, you'll be able to convert to a log in no time. And you'll just convert it, so it won't matter. You'll still get the same answer. So we'll get 2x minus 3, just takes longer, equals 0. 2x equals 3. X equals 3/2. Box it because I'm proud of it, because it's the right answer. Then we're going to flip over. Some people say, okay, this is, oh my gosh, common error 101. People put these together and say 128x. You cannot. The 32, the x is attached to the 32. Do you see that? If you're someone who's like, I'm totally going to multiply those together, you need to write yourself a little note with a highlighter and say, you cannot multiply these together. And if you're like, I'll never do that, 80% of you will. Until I like literally get you to stop doing it, practicing it over and over and over. Okay? I can't divide the 4 over either. If I divide the 4 over, the 2 has an exponent. Do you see that? Last example, I went and I divided 40 by 5. 40 divided by 5 is 8. That's fine. If I divide the 4 over, I'm still in trouble. I still have this 2 with an exponent on it. It makes it no better for me. Okay? So, you cannot make these join. You cannot divide that over and fix the problem. But what can you do to all three of these numbers?
Make them base 2.
Make them base 2. So, this is 2 to the x minus 3 equals 2 squared times 2 to the 5x. Now, what I get all the time, if people don't mess up and first off put that to 128, which, seriously, that is the first thing. I'll see 128, and I'm like, well, it's easy to mark. It's a 0. You immediately have a 0 if you put those two numbers together. Okay? So don't do that. Then this is the second error. People will drop the bases. My rule of what I said to you when you can drop the bases is if you have smiley face to the something equals smiley face to the something. Did I say if it was smiley face to something equals smiley face to the something times smiley face to the something? Was that the rule? No. It had to be a smiley face on one side, smiley face on the other. A 2 on one side, a 2 on the other. A 4 on one side, a 4 on the other. So before I drop exponents, I actually have to put these two together. Because if you just drop exponents, those are being multiplied, are they not? And are they actually being multiplied with exponential laws? No, they're being what? Added. So do you think they'll have the oopsie to you multiplying them? That would be my next oopsie that I would pick. So we have 2 to the x minus 3 equals 2 to the 2 plus 5x. Now do I have two bases, one on one side, one on the other? Are they the same? Yes, so now I'm back to where I was on the previous page, and I can just set the exponents equal, right? 2 to the something equals 2 to the something. I can set the somethings equal. So I'm going to go x minus 3 equals 2 plus 5x. Subtract x. First thing you do is get your x's together. Negative 3 equals 2 plus 4x. Subtract 2. Negative 5 equals 4x. Divide by 4. X equals negative 5 over 4. What base can we make 2 all be? Can I divide the 3 over? No, this has an exponent. Can I make the 3 into the 81? No, the 81 has an exponent. So what base can I make them all be? Base 3. 9 is 3 to, or 1 over 9 is 3 to the negative 2. This is 3 to the 1. Don't forget there's a 1 on here. That will happen. People will screw this up and they'll think it's a 0. And then this is 3 to the 4. Try it out. And I want you to try this one and this one. We said 1 over 9 is 3 to the 3 to the negative 2. X plus 1. And then I always say 3 to the 1. Do you see how if you forget to put the 1, you might just completely think it's a 0? People do, and you're like, I would not. They do. And the reason why I say all these little common errors is because I see them constantly. I don't say them because I'm making them up. Okay? I'll tell you, this is where the error exists. If you're like, yeah, I wouldn't have put a 1 there, I would have put a 0. Then you leave yourself a highlighted note and say, remember to put a 1 there. Because if you're the only person who knows if you would have done that error. Right? I don't know. I just know it's an error that happens way more than it should. And I know why it does, because it doesn't have an exponent. And then this would be 3 to the 4 to the 2x plus 1. Remember, your notes are for you, not for me. We distribute and distribute, so we're going to get 3 to the negative 2x minus 2 equals 3 to the 1 times 3 to the 8x plus 4. And then we get 3 to the negative 2x minus 2 equals 3 to the 8x plus 5. And then we have two bases that are the same. So we can go negative 2x minus 2 equals 8x plus 5. And then I'm going to add my 2x. And I get negative 2 equals 10x plus 5. Subtract 5. 10x equals negative 7. X equals negative 7. Okay. We can make these all be base 2. We agree? So 8, this is 8 to the half, technically, is it not? So we can go 2 to the 3 to the half equals 2 to the 1 times 2 to the 4 x plus 1. So I get 2 to the 3 halves equals 2 to the 1 times 2 to the 4x plus 4. And so we get 2 to the 3 halves equals 2 to the 4x plus 5. Then these equal, so I get 3 halves equals 4x plus 5. Subtract 5. And so I get 3 over 2 minus 10 over 2.
2 to the 1?
Me?
Oh, no, never mind. You added it to 5. I'm sorry. I'm a little slow.
Da, 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 da. I often make mistakes, and I didn't this time. Boom. Yeah. Hey, that dance was not a mistake. That dance was a mess. All right. You guys are just jealous. Hate is going to hate. It's fine. Negative 7 over 2 divided by, or equals 4x, divided by 4. Dividing by 4 is like multiplying by a quarter. So. I haven't volunteered to supervise the dance, but I think maybe I should. Got all the moves. Yeah.
Would that radical also be like a negative on the outside? Is it squared to be, or is that you know, you have like positive, negative radical or something?
Nope. You only have plus or minus radicals when you physically take the square root with your arm. So this was given to you as square root 8. So that is positive root 8. So it's if you have x squared equals 8, and you physically take the square root with your arm, you put plus or minus when you're solving. This was root 8, so if it's given to you in printed form, then it is what it is. So it's either negative root 8 or positive root 8, whatever they give you. Yeah. Okay. A bunch of tries. Go. This is your homework. Also, do I have to give you an answer key? No. Why did I not give you one? So I'm going to make you check it.